Today, insects are some of the most, albeit in many cases irrationally, feared animals in the world. The idea of a giant, winged, six-legged invertebrate lurking in the corners of our houses is enough to keep many people awake at night. But what if you were to turn the clock back to the age of the dinosaurs? What kind of gigantic insects would you be able to encounter then? In today's video, you'll be finding out. Today, we will be meeting monstrous ancient relatives of cockroaches, lacewings, grasshoppers, and more, as we focus on the very largest insects that coexisted with the dinosaurs. Grab your bug spray, sit back, and try to relax as we introduce you to some of the largest insects to have shared the world with the dinosaurs. Around the time the very first dinosaurs were beginning to appear on planet Earth, the skies were filled with an array of bizarre, unconventional animals. Around 230 to 220 million years ago in what is today Kyrgyzstan, dense forests prospered, filled with odd gliding vertebrates and even odder insects. One such invertebrate was Gigatitan vulgaris, a large predatory insect from the Madigan Formation. This was the largest member of a group of very large insects known as Titanopterans, related to modern grasshoppers. Despite this connection to locusts and crickets, Gigatitan would have resembled a gigantic praying mantis with a 16-inch or 40-centimeter wingspan. Despite the immense wingspan, the current consensus on Gigatitan is that it was probably not capable of powered flight. Roughly 150% larger than the very largest of its modern relatives, Gigatitan likely could not lift its body off the ground using its wings, as massive as they were. Rather, Gigatitan probably used its wings to glide, ambushing prey from nearby branches. Like most insects, it would likely have been an adept climber and used this to its advantage when finding higher ground to strike from. Gigatitan's wings did, however, serve another purpose: intimidation. Fossils of Gigatitan have immaculately preserved dark, striped patterns on the wings that, in the right light, could have produced flashes of color to make an animal look much larger and more dangerous to its own predators. As big and as powerful as this giant bug was, several insectivorous vertebrates from the region could still have taken Gigatitan as prey. Flashing its wings in this way may have put would-be attackers off, allowing the insect to hunt another day. Gigatitan's forelimbs had evolved into spiky, grasping appendages that could render prey immobile when the giant insect reached out to catch a meal. This is a feature seen in modern-day mantises, who then bring their food to their mandibles to dispatch and consume. While Gigatitan likely fed on various species of smaller invertebrates native to the Madigan Formation, it shared the ancient Triassic treetops with several bizarre vertebrates that would have been the correct size and shape for the insect to hunt. One such vertebrate was Charopteryx, a strange arboreal reptile that used stretches of skin on its elongated legs to glide from tree to tree. Like many insects, it may also have been an opportunistic scavenger, leaping down from the trees to descend upon carcasses for an easy meal. Before Gigatitan came along, Titanopterans were already proving themselves as some of the most fearsome insects in the fossil record. The Anisean stage of the Triassic, roughly 10 or so million years before the fauna of the Madigan Formation evolved, was known to harbor Gigatitan's earliest relatives. Clatrotitan was one such insect, known from what is today Australia. Its wingspan was roughly 27 centimeters across, substantially smaller than Gigatitan, but still no small fry when it came to insects in general. Like Gigatitan, this Titanopteran likely stalked prey amidst the treetops, descending on them from above with its huge developed forelimbs to grasp and tear at unfortunate victims. Today, lacewings, delicate insects of the order Neuroptera, are a large, diverse group of animals. Over 6,000 Neuropterans are known to science, and this order contains not only the lacewings, but their mantid fly and antlion relatives. Today, most species of lacewing feed upon pollen and nectar, but many species will turn their attention to small insects such as aphids when they're available. They are typically regarded as handy pest control assistants for gardeners and generally are a delight to spot. You might not be able to say the same for all of their prehistoric relatives, however. One of the most intriguing lacewing fossils comes from the Middle Cretaceous of what is today Myanmar, something of a hotbed for large Mesozoic insect fossils. Preserved for over 100 million years in amber from Myanmar's Hukong Valley are the remains of an insect known as Pedinoptera arachnophilia, a predatory lacewing that appears to have been a specialized hunter, and this one was only a baby. Although both young and adult Pedinoptera are known from the site, the young seem to have been remarkably well adapted for hunting some of the most conventionally fearsome invertebrates, the tropical spiders that littered the forest floor of ancient Myanmar. These young Neuropterans were superficially maggot-like in appearance, with thick bodies that ended in a set of long mandibles. Most remarkable, though, are the insect's legs. Their limbs were incredibly long and spindly. These insects could almost have passed for spiders themselves to the untrained eye. Paleontologists have commented that these legs, all of which were tipped with thin, sharp claws, may have been used to help the insect travel along the silk webs of ancient spiders without getting ensnared themselves. When a spider entered the lacewing's range, it would strike using the sharp mandibles at the end of its head, successfully ensnaring an arachnid appetizer. While modern lacewing larvae are known to prefer aphids to plant matter, their ancient relatives appear to have taken hunting to an extreme and appear to have been remarkably good at it. Moreover, adult Pedinoptera did not seem to lose their taste for invertebrate flesh, retaining the sharp jaws that would have been useful for dispatching prey later in life. Unlike their young, however, they seem to have been generalist hunters that were capable of hunting a wide range of insects, not just spiders. Of course, not all Mesozoic lacewings were stealthy hunters. Some evolved to superficially resemble other groups of insects. While these other groups of ancient lacewings were not carnivorous, they were remarkable and large. Take Orogramma illesabrosa, for example. Upon the first glance of this amazingly preserved fossil, one might assume that a large butterfly or moth has been preserved in these early Cretaceous rocks from China. Rather, this was a perfect example of convergent evolution, where a lacewing has evolved to superficially resemble butterflies and moths. Convergent evolution is a common process in the modern animal kingdom, where two completely unrelated organisms evolve the same traits in response to an environment or food source. It can and does happen on a much larger scale than lacewings and butterflies, however, and can be seen on every single one of the world's continents throughout natural history. Basking sharks and whales are both very large and have adaptations to help them filter invertebrates from the seas. Aardvarks and anteaters are unrelated, but both have long snouts and strong digging claws to help them break into insect mounds. Here we see a lacewing that has evolved broad, thick wings with remarkable spot-like patterns on them, just as we see butterflies in the modern day that have evolved the same features in response to their environment. Orogramma was a large insect that fed on pollen and boasted these incredible wings likely to display to potential mates or to deter predators. It shared the ancient Chinese forests with many species of early bird and feathered theropod dinosaur that would have jumped at the chance to consume such a large, juicy bug. Such lacewings were not confined to the forests of Asia, however. and one exceptionally remarkable species, Macarkinia erme, is known from what would eventually become Brazil. Another lacewing species that superficially resembled a butterfly, this genus boasted prominent hind wings that featured large eye spots, likely for deterring predators. Much larger than modern lacewings, these insects are closely known from Brazil's Araripe Basin, which dates back to around 115 million years ago. These large lacewings would have had to contend with several species of pterosaur, which likely darted through the air after them in dramatic acrobatic hunts. Cockroaches are widely seen as repulsive household pests across much of the modern world. Known for infesting dwellings in order to seek out human food, we pay top dollar to eradicate these hardy insects, which are capable of withstanding a great deal of damage. Most modern cockroaches are unfussy eaters and will chow down on anything from fruit and vegetables to meat and starches. One notable species of prehistoric roach, however, was a keen predator. Also known from the ancient forests of Myanmar, Manipulator modificaputus was a mantis-like carnivore that had adapted to snatching nocturnal prey amidst the leaf litter of dark Cretaceous woodlands. Unlike the other animals on this list, it was not a giant, measuring just 1 centimeter long, but it boasted various characteristics that would have made it a very successful carnivore amidst these dark forests. The aptly named Manipulator would have been readily capable of snatching arthropods from the forest floor using its modified legs, which were covered in a series of short but exceedingly sharp spines. These spines would have helped the roach hold its prey in place as it ate its victim alive using tough mandibles. Its body was narrow and spindly, somewhat resembling modern-day crane flies, and it was indeed capable of flight, perhaps darting through the night in search of more abundant feeding grounds. The predator has been well preserved in amber, giving scientists essentially a picturesque look at this animal in the flesh. The fossils clearly show the modified forelimbs, sharp spines, and delicate wings that would have allowed this animal to terrorize the leaf litter during the age of the dinosaurs. While it was not exactly Gigatitan, this miniature menace would have been monstrous to the very smallest residents of Cretaceous Myanmar. All of the insects we've discussed in this video are large, fearsome, or a combination of the two. But all of them pale in comparison to the gigantic invertebrates of the Carboniferous, a period of the Paleozoic era long before the dinosaurs arrived on the scene. Around 300 million years ago, much of the world was covered in dense swamp forests, where oxygen content in the Earth's atmosphere was over 15% higher than usual. This allowed invertebrates, including insects, to reach truly monstrous sizes. Nowhere is this better demonstrated in the fossil record than the famous giant dragonfly relatives Meganeura and Meganeuropsis, the latter of which was actually known from the early Permian, which succeeded the Carboniferous. With wingspans matching the length of those seen in small birds of prey, these insects hunted on the wing, picking off insects and vertebrates alike from the swampy forest floor in which they thrived. Also found in the Carboniferous swamp forests were the Dinosaurs, a group of early winged insects which were capable of growing to immense sizes during this time of heightened oxygen levels in the atmosphere. Mesozoic enormous is one such giant, and would also have resembled a dragonfly in life, albeit one with a very broad abdomen and streamer-like appendages trailing from the end of its tail. While gigantic, this group of insects is believed to have been primarily herbivorous. So that was a tour through time of some of the most awe-inspiring, terrifying, and toughest insects that have been found amidst the fossils of dinosaurs. It's important to remember that insects are, and have been for millions of years, some of the most common animals on Earth. For every Gigatitan and Titanoptera-like insect that has fossilized and been discovered by scientists, there are likely thousands of species that have not. In the modern day alone, over 1 million species of insect have been discovered and described, and there may be as many as 9 million that are yet to be studied. Just imagine what kinds of secrets the previous hundreds of millions of years of insect evolution might be hiding.